Hello, welcome to the mysterious life of web apps in the background. My name is Maximiliano Firtman. I'm Firt on Twitter, and I'm a mobile web developer. I'm currently in Argentina, that's my home, and when there is no pandemic, I'm typically a frequent flyer. I've been doing web since that version of Netscape that you see on the screen. I've been doing consulting and trainings at big companies, also small companies around the world, as well as publishing video courses at different places such as Pluralsight, O'Reilly, and LinkedIn Learning. I've been writing a lot, lately on PWAs and web performance. And finally, I have just launched my new website, firt.dev, where you can find more information about the topics that we will be covering today. So, there is a mysterious life of web apps in the background because what happens with our web app, with our PWA, or just a normal website when the user sends that app to the background, or when the user sends the browser to the background? We actually don't know. We are not sure what happens with our content, with our timers, and with our threads. So why we should care about this? Well, first, to improve user experience. That's the first important part, because sometimes if we don't know what's going on, when we're going back to the app from the background, the experience is not the best one. Also to save resources, energy, memory, CPU usage, and storage, because when we are in the background, we should change what we are doing. Also to stop timers, and something similar happens with pending requests. If you are requesting data from the server, or if you have a WebSocket, for example, you should stop that in the background if you want to, and if you know what you're doing. So let's reveal the mystery. For that, we will be spying in the background. So I created some kind of a hidden camera to spy on web apps in the background. And we're going to see frames per second. So what happens with frame rate in the background? What happens with our timers, such as set interval or set timeout? So what happens with the frequency and execution rights for timers? Also, we will see what happens with web workers if we have timers inside the worker thread. And finally, something similar but with service workers, not with thread workers. For that, I have created this website that will give us the current information on frames per second on requestAnimationFrame, then animation like CSS animation, what happens with the CSS animation, the timer frequency, so we will see there if there is some throttling in timer execution, as well as at the bottom, worker thread and service worker. So let's see this in action. Let's start with Google Chrome on desktop. In this case, we have a tab, we can see it's live, everything is running. But what happens, for example, if you now go and open a new tab? In that case, it goes to hidden, and basically when it goes to hidden, we can detect that with JavaScript, and now we don't have CSS animation, and we don't have requestAnimationFrame. So if we are using that API won't be fired because we are not visible on the screen. However, looking at the timer frequency, in that case, we have a throttle, and right now it's actually to 1 second. So if you have, not matter the frequency that you set up in your set timeout or set interval, you will be executed once per second. But your worker thread and your service worker are fully 100%. So they can still execute code at 100% speed in terms of throttling. So there is no throttling on the worker thread or in the service worker. Of course, if you go back to that tab, it will start running again in case of the animation, frame per second, and requestAnimationFrame. If we minimize the window, it's exactly the same. It's like opening a new tab because actually it's not visible. When you go back, it's exactly the same again. And if you close the tab, or even if you close the browser, of course, now the page is stopped. The worker thread is stopped, but not the service worker, because the service worker, we know, has its own life cycle, and it will still be there for a while. It depends on the browser. Now let's see Firefox. In this case, I have the same URL on Firefox on desktop. We can see that it's live, and if you open a new tab, something similar happens here. It goes to hidden, and now everything goes down. And when you go back, everything goes up again. Also on desktop, what happens is that it will be hidden if you are covering the window with other windows. So you don't need to minimize on desktop. Also, when you are fully covering an app, it will be the same. It will be just like hidden. And if you close the tab, you will see that also the service worker will still be running, but just for a few seconds, and then it will go to stopped. Finally, Safari on macOS. We can see something similar when it's live. If we open a new tab, something similar happens, but you will see that here the whole page seems to be stopped really quickly, including the thread and the service worker. And if you wait here a couple of seconds, we will see that it goes live and it goes down every once in a while. So actually it's changing the behavior of Safari, and it's actually executing your timers and everything every 10 seconds. So background apps in the desktop operating systems, Windows, macOS, Linux, and Chrome OS, our web app will not be visible when the tab is in the background. When the browser, the whole browser is in the background, if it's a PWA in a standalone mode, it's when the PWA is in the background, and also when the PWA or the website is totally covered by another window. Those are the situations. In this case, all the web apps, when they are open, visible or not, it doesn't matter if they're visible or not, they are in memory and they have execution rights. But when they're not visible, there will be some limits on the timers, so some throttling on timers from 1 to 10 seconds. And also some situations might also suspend them. In that case, no timer execution will happen. This is currently typically happening on Chromium browsers that are not Chrome, not Google Chrome. For example, Brave or Sidekick. So these browsers are targeting users who want to save battery. So basically when a tab is in the background or is hidden, they will freeze the tab, they will suspend the tab, and sometimes they might even discard the tab from memory. Remember that service workers have their own lifecycle, so they might still be running there for a while. Now it's time to talk about mobile operating system. Let's start with the iPhone. In this case, I have an iPhone with Safari. I'm running the same URL, and let's see what happens. When we are opening a new tab, something similar to desktop happened with one particular difference. The timer frequency is actually greater than on Safari desktop. On Safari desktop, the throttling can be around 10 seconds, and here the throttling is 500 milliseconds. So while in the background, our web app can execute timers once per half a second. But the worker thread is there up and running, so no problem with the worker thread. Let's see what happens when we go back. As expectable, it will start again, so everything is running again. But now let's see what happens on other situations, such as when we open the task manager. When we open the task manager or the multi-window, you're still visible until you go to another app. So you need to wait for going to another app to actually be hidden. And in this case, you can see that this immediately stopped. Everything is stopped after 2 to 3 seconds. So to be honest, here on my testing, I found a lot of situations where my web app were running for 30 seconds. So sometimes it's 2 seconds, sometimes it's 30 seconds in the background. I couldn't actually understand why it's not exactly the same on every execution. So now let's see what happens with the PWA. So if we install these websites in the home screen. In this case, it's a standalone application, so it will look like any other app in the system. If we go to the home screen, for example, it will stay there for 2 seconds and then everything is stopped. Also the worker thread, so everything is stopped, okay? If we go back, everything restarts, so it was still in memory. It's not deleting the app from memory, okay? Makes sense? And something weird, look at this. If I open Air Horner, that's another PWA. So Air Horner is not our PWA. Now it's running, but our PWA is also running. So this is weird. When you open a PWA, all the PWAs that are still in memory are also executing again. So I think it's like unexpected behavior. I don't think this this was on purpose. I don't want to say a bug, but it's something weird. So when you open a PWA, if there are other PWAs in memory that are suspended, so they're not executing code, now they can execute code again. Okay, so it's like the PWA engine, when it has execution rights, it will let all the PWAs to execute. So that's a weird one, to be honest. And of course, if you close that PWA, in that case, it's not in memory anymore, so now it's stopped. So background web apps in mobile. iOS and iPadOS, our PWA or web app won't be visible if we lock the screen, so when you turn off your phone, if you go to the home screen, if you open another tab, or if you open another app. In that case, web apps in the background can be memory or not. It depends on the OS. So if they are in memory, you will have different behavior when you go back to the app. If you go back to the app, it's still in memory, so it will defreeze. And if it's not in memory anymore, it will start from scratch. The UI that you see when you are seeing all the apps open, it's actually a screenshot. It's not actually updated. So if you can execute code in the background, be careful, because if you change the DOM or anything on the screen, it won't appear in the user's interface. It's just a screenshot what you see there. And you will have 2 or 30 seconds of execution after leaving foreground. Again, I'm not yet sure why that happens, why sometimes it's 30 seconds, sometimes it's 2 seconds, but that's the time that you have to execute code in the background when you get off the foreground. And if the PWA is still in memory, opening other PWAs that is not your PWA will also give your PWA execution rights. So you will be able to execute code in the background when the user is using other PWAs. That's a weird one. So we saw desktop and iOS. It's time for Android. So this is the same PWA on Android. When we start, we have the same situation here. Everything is on. When we open a new tab, of course, we go to hidden and everything goes down a little bit. We also have a throttle in the timers. So timers are also throttled as expected. And now let's see what happens when we go to the home screen. Now our PWA is hidden. Of course, frames rates are 0, so they are completely down. And the frequency of the timer is also throttled. The worker thread and the service worker are fully capable, so they're still executing code, even if you're continue using your phone, okay? And the weird part is that will be there for 5 minutes. So our app will be there for 5 minutes, unless you, as you saw here, you just kill the app. In that case, it will be stopped, or unless the system needs memory and it will kill your app. So you have 5 minutes or less to execute code in the background. Now PWA, so if you install that website as a PWA, in this case, it's actually a similar situation because it acts like a browser tab using Chrome. I'm still using Chrome here. So something that happens that here in Android is that when you open the multitask manager, in different OS it has different names, your web app goes to hidden. So if you see here, it's hidden now, even if I'm still there, right? So that's not happening on iOS. On iOS, your app is still visible unless you actually change the active app. But here, if you access this this screen to select other apps, you're actually in the background. Let's see now what happens if I change my app. When I go in back, it goes visible again. And if you go to the home screen, it's hidden and it will still be there running for 5 minutes, as I mentioned before. So background apps in mobile operating systems. On Android, the app will not be visible, so will be hidden. If you go to the lock screen, so you turn off your phone. If you go to the home screen, if you open the multitask manager, so that's different. That's a difference compared with iOS. If you open other tab or if you open other app, okay? And web apps in the background can be memory or not, similar to iOS. The UI is again just a screenshot, so when you are in the background executing code, be very careful. You don't have complete power to do wherever you want. And on Chrome, you will have up to 5 minutes of execution in the background. Okay, remember it can be less if the user is actually killing the app or throwing the app away, or if the system needs memory. There are 30 more seconds for the service worker. So the service worker has actually 5.5 minutes to execute. If you're using other browsers, for example on Firefox, the page is stopped immediately. So on Firefox, when you go to the background, the page is stopped immediately with your timers, with everything you have there. But the service worker will have 30 seconds, and the worker thread will have 3 minutes in the background. So on Firefox on Android, if you need to do something in the background, I know, like updating data, it should be done in the worker, not in the main context, because it's being stopped immediately. So as a summary, this is a diagram, and don't take this as the final word, because algorithms are complex and it differs per version, and there are a lot of situations around this. But freezing, the first row here, is the ability, when you go to the background, the ability that the browser has to actually freeze your app, so it's not going to execute any code anymore. Okay, it's still in memory without execution. Destroy has to do with, okay, you were frozen, and you know what? You're done. I'm going to destroy you. And in that case, it won't be in memory anymore, so if the user goes back to the app, it's not going to work. So in terms of timer throttling, on desktop, it's typically 1 second, that's the average, on Firefox and Chrome. Safari is going through throttle by typically 10 seconds. So on the first 3 seconds, you might get a couple of executions in the background, but after that, 10 seconds will be actually the actual timer. And something similar happens on Chrome after 5 minutes. So after a tab or a PWA is hidden for 5 minutes, then the throttling will jump to 1 minute. So then 1 timer every minute, okay? And on mobile, it's 1 second on Chrome and Firefox, and half a second on iOS and iPadOS. So in the background, your timers will actually be fired every 500 milliseconds. Regarding the worker thread, actually they have more power. So if you create the web worker in JavaScript, they will have more power compared with the standard timers. So on desktop, they have unlimited power in the background. Again, there might be some exceptions to that, but by default, it's unlimited. On Android Chromium, it's 5 minutes. On Android Firefox, it's 3 minutes. And on iOS and iPadOS, it's the same 2 seconds to 30 seconds, right? And the service worker, we need to remember, it has its own life cycle. And here, it seems to have more power on Chromium. That if you're in the service worker doing stuff, like using actually CPU, you can be there up to 5 minutes, 5 minutes, dot 5 actually. And on Firefox, it doesn't matter. After 30 seconds, it will kill you. The same as Safari, that it will typically kill you on 10 seconds. So it doesn't matter if you're still doing things, you have only 10 seconds. Okay, cool. So background detection. So how can you detect if the user goes to the background that now you know what happens? Well, typically we're going to use visibility change detection. And this is available on all platforms. And we can detect when the user is going to running, to pause state, to running, or pause to running. And in this case, we use the event listener visibility change. So it's actually pretty simple. A window at event listener visibility change, and you're going to check for the current visibility state. It can be hidden or visible. If it's hidden, it means that you are now in the background. Okay, or in desktop, maybe you're not in the background in terms of minimized, or maybe there is another window on top of your window, and that's not visible. Okay, that's hidden. So remember that. And in this case, now you should know that your timers will be throttled, for example. And on mobile devices, your life expectation is not the same. That means that you might be suspended in a couple of seconds or minutes. On Chromium browsers, you can also detect when you go to freeze. In that case, you can detect the event listener freeze. Freeze is actually when you will still be in memory, but without any execution. And for example, you can save the current app state. And because we have freeze, we have resume. In this case, you're going back from suspension, and there is no need to restore that state because you were still in memory. Okay, so you are only defreezing yourself. Sometimes on some operating systems, it might happen that when you go back to the app or to the web app, it's not there in memory anymore. If that's the case, resume won't be executed. The web app will start from scratch. But what you can do is actually listen for dump content loaded, so when the page starts, and check the document was discarded Boolean property. If that property is true, it means that the user is going back to a web app that was discarded from memory. So that's the point, the moment where you should actually restore the saved state. So on mobile devices today, to be honest, this Page Lifecycle API, so freeze and resume, it's typically not available. So if you want to be multi-platform, you can save the state on visibility change. That's available everywhere, visibility change. And you can include a timestamp in local storage, for example, at which moment the user went to the background. So, and you are going to restore the state when the page loads, and using the saved timestamp, you can decide if you want to restore the state or if you want to start a new navigation. For example, you're going back to the app and you see the difference of timestamp is 2 minutes. And you say, yeah, it's like the same session, only 2 minutes. 2 minutes have happened between sessions. So you restore the state. But maybe a week has happened between sessions because the user can go to the previous app from a week ago. And in that case, you will start from scratch, probably. Okay, so that's actually a good idea. So what if you want to still execute code in the background? Today, you have just a couple of options if you still want to execute code in the background. Google Play Store, so you need to create a PWA to the Google Play Store with trusted web activity, and then the native code will be executed in the background. Or the App Store for PWAs on iOS and iPadOS using a WebView and native code for the background. Something similar for Windows on the Microsoft Store. You create a universal Windows app that will use APIs that will let you execute code in the background. Or if you can use Service Worker background APIs. If you don't want the store, you still want to execute this in the browser, there are some additional APIs available at the Service Worker scenario or around the Service Worker scenario. So these options are abilities on top of the main spec. They're typically today only on Chromium-based browsers. Chrome, Google Chrome, Microsoft Edge, Samsung Internet Browser, Brave sometimes. It depends on the browser. And remember that when you execute code in the background, there may be no client running at that time, so no page. So if you want to show something on the screen, you cannot do that. So you need to use other techniques such as web notifications. So in this umbrella, we have web push, background sync, periodic background sync that will let you execute the service worker every once in a while, such as every hour or every morning. Then in that case, your service worker from a stop will be actually live and you can execute code in the background. Okay, there are some restrictions on when the browser will grant you permission for periodic background sync, but this is actually one way you have. And finally, background fetch that will let you download files, big files, when the user is not actually using your web app. So these are the ways that we have today to actually bypass these limitations when we are in the background. And if you're using a Chromium-based browsers, you can go to DevTools. Within application, you will find on the service worker side a whole section to test these APIs. And also within application, background services, you can actually record and see what's going on in the background with your web app or your PWA. Well, that's all for the mysterious life of web apps in the background. So now you actually know what's going on in the background, or you have an idea of what's going on. Sometimes your app is still executing, Sometimes only the worker thread is executing, fully executed. Sometimes your timers are throttled, and sometimes your app will go to a suspended state. So it will go through a freeze action. In that case, you will still be in memory, but without executing any code. And sometimes that memory web app will also be discarded by the OS. So now you know better about the life of web apps in the background. I hope it was useful for you. I hope we can meet again in person sometime in the future. So thank you very much, and let's chat. Let's continue this conversation.
Hey, Max. Sorry for the delay in getting to you.
No worries.
Congratulations on an amazing talk. I think I need to give you a second round of applause. So talk to me. While we're waiting for a few Q&A questions to come in, what do you wish would happen in the background when your application goes out? What would be your dream bit of functionality?
Well, it's complicated because as developers, we typically want to have full power. So we want to do whatever we want to do, but the problem is that they have the penalty, right? So we are talking about the user's battery, and mostly on mobile devices, and that's a problem. And also on desktops, even if you're on a desktop computer and you're charging your computer, the problem is that you're using CPU, and we typically left a lot of background tabs open, and that's typically a problem. So it's difficult to actually find the balance between power and or use cases that we actually want to support, and so to keep the device healthy. And that's why it's important to understand what happens. So right now, what I see on a lot of web apps is that they're not actually completely aware of that life cycle in the background. So it's just that they're not actually doing any specific code for that situation. And then maybe you come back to that web app a week later, and it was still in memory. Sometimes that happens. And maybe the situation, it's kind of weird because you see like all data and something from a user's point of view, it's a bad user experience. So that's why I think it's important to understand what's going on in the background.
I know, but what would be your dream? What capabilities would you want?
So I think that the capabilities that we have today are on Chromium are pretty good. For example, the periodic sync that lets you execute code every once in a while, only if the user has site engagement with that website. So, I mean, if you're not using that website, it will not grant permission for that. What we don't have right now, it's a clear idea of what's going on and when do you get the right high engagement to do that. Something that a lot of apps they really want to do, but it's actually really dangerous as well, is to geolocate the user in the background. So, and I'm not talking about like VR apps that they're doing like bad stuff, but sometimes you have an app, for example, that you wanna know when you need to get out of the metro or the underground, and for that, you need to like continue looking at the geolocation in the background or accessing geofencing features. That's something that I'm seeing a lot of developers wanting to do that in the background. So, like for using the geolocation right now, fortunately that's currently limited. Yes. So because there is a big discussion there.
Yeah, very fortunately. I don't think I would like knowing that web pages could track my location in the background. I really would not be a fan of that. So we
also have the problem with native apps. So.
True. I have very few of those. I rely more on web apps personally. But enough about me. Christopher Jenner. Hi Chris, another person from Cornwall. Chris has asked if the user's denied cookies to be used within the web browser, can you still keep users' data? I don't think he said it doesn't think it's part of the talk, but I thought you might be able to answer.
No, that's fine. I'm trying to understand the question. So you could be nice cookies. How would you be able to still keep your users' data? I'm not sure I understand the question, but I guess that the answer is around the APIs that we have available for storage, like web storage that most people know as local storage or IndexedDB or something like that. So if the user is denying cookies, those storages will still be there unless the user is in incognito mode or private mode or however you want to call that on each browser. So I'm not sure if that's the answer or not. If you're trying to spy on the user, that's not good. So don't do that at home. But for some use cases where you actually want to store data, I think that you need to look at those APIs that the browsers are supporting.
Okay, Chris, if you wanted a more clarification around that, just clarify your question there. So Milos has said, is there any case where you should start looking into what happens in the background before you actually see the bug or some performance issues happening?
Mm-hmm. The thing is that as in the research that you saw in the talk, so I've seen that if you're using a web worker, that web worker is actually fully powered on most platforms in the background. So if you have a while true, or if you have a set timeout or a set interval that is executing code every 10 milliseconds, I'm not sure if 10 milliseconds will be granted, but anyway, you will probably get a lot of execution and CPU usage in the background for up to 5 minutes, for example, on Android. That's a lot, right? So if you have a bug there, it's actually a problem because the throttle is happening in the main thread, in the UI thread, or in the JavaScript global context. But service workers also have their own more restricted situation there. So service workers sometimes they have a timer like, okay, 30 seconds, after 30 seconds, you are down. But I've seen that web workers, like a normal thread, has more power. So you can keep a connection to the server there. And if you have a bug, you can maybe send thousands of requests to the network in the background, and nobody's actually realizing that that's happening because the web app is not on the screen. So unless you actually check battery usage, you will never know.
Okay. Do you think that there's some education that needs to be done around users, around how this kind of stuff works in the background, or is it solely the responsibility of the developer?
I think it's a developer because I don't think the user will need to know about this and what's going on. In fact, the user thinks that when something is in the background, it's not executing code. That's like the normal expectation, right? But now that's not happening on Android. For 5 minutes, your last website can still be executing code. And executing code means sending data to the server or downloading data from the server. And sometimes we want that. So that's why some APIs that are available at the Chromium side are useful, because they're trying to match specific use cases and not just giving you power to do wherever you want in the background. But we also have this problem that because we are not in the foreground, there is no way to notify the user. The only way is web notifications, but for that the user needs to grant you permission for push notification. That we know it's kind of a weird part of the web today, the push notifications. And so it's a challenge to actually do something in the background and notify the user.
I'm not sure anybody's ever actually switched on web notifications.
Well, I mean, there are situations. I mean, your mail, Gmail, calendars, apps. True. So on those situations, typically you say, well, yeah, I want notifications, but yeah, for standard websites, it's difficult. So that's why maybe in the future we will see something moving into, okay, if it's a PWA, it's an installable app, maybe it makes sense for that. But it's just the website that you're visiting. Yeah, it's weird.
It is. So we've got 3 minutes left and 2 questions. So hopefully we'll be able to go through these quite quickly. Are there any specific security aspects that need to be considered when executing code in the background?
Well, if you're just executing code with the research I did, that's just pure JavaScript, and it's just in the umbrella of the browser. So it's just the same thing. If you're talking about the APIs that I covered really briefly, I just mentioned the APIs that will let you execute code in the background, despite if the web app has just been minimized or not, like a background sync, periodic background sync, web push. So on those situations, the only thing that has to do with security is that you're not in the main JavaScript context. You're in the service workers context.
Yeah.
So you need to understand what's possible there. So not everything is possible when you are running code in a service worker. But we are still under the umbrella of the web platform. So it's always the same thing. Unless we found a bug or something like that, we don't have big security risks because we are still running code within the browser and within the execution engine that the browser is offering to us. So it's not native code. Okay, even if you're running WebAssembly, I mean, you don't have access to native APIs. So it's just the same security concerns as in the foreground.
Okay, perfect answer. Can you explain how you set up your investigation? How do you measure what is running in the background?
So it was a simple implementation. I set up a node.js server that using WebSockets, and also I have a fallback to the Fetch API, and I have timers. There is a client side and a dashboard. That's what you see two screens there. The dashboard is just HTML and is receiving data from the server, and the client is sending data to the server. And I have a web worker that has a set interval, executing code, trying to execute code 60 frames per second. On the same on the service worker. And I have something similar on the JavaScript global context object. I have a set interval. I have a requestAnimationFrame code. And for the animation to check what happens with CSS animations, I'm using the Web Animation API. Yeah. There are another way to do that is using the on animation events. We have a couple of animation events at the DOM level. So you can actually check on every iteration, on animation iteration, I think that's the name of the event. On every iteration of the animation, you can have a callback. And I have just a counter. I'm counting the how many times the browser is calling that callback. Yeah. Every once in a while, I'm sending that data through WebSockets to the server.
Perfect. That was a really good answer. We're going to have to call a close here. Natalia's talk is just starting over on YouTube. But Maximiliano, thank you very much for giving your talk and taking the time. I'm looking forward to watching back and really diving into this kind of stuff. So we'll see you hopefully next year in person, I guess.
Yeah, sure, of course.